All right, we're going to look at our last section, section 6.5, trapezoids and kites. In a trapezoid, the bases are the parallel sides. Base angles are two angles that share a base. And we have two examples of triangles below. So we have one pair of parallel sides. Then these are our bases. So we have one base, two base, one leg, and two leg. So same thing here. Here's our parallel sides, base, base, leg, leg. There are three trapezoid theorems. The first one says the two angles of a trapezoid that share a leg are supplementary. So if we look at our trapezoid up above, ABCD, that means that angle A plus angle B would equal 180, and angle C plus angle D would equal 180. Number two, the base angles of an isosceles trapezoid are congruent. So if we're told we have an isosceles trapezoid, that would make angle A congruent to angle D, and angle B congruent to angle C. And finally, the diagonals of an isosceles trapezoid are congruent. So that means AC would be congruent to BD. All right, let's look at number one. We have WXYZ is an isosceles trapezoid, and the measure of angle X is 156 degrees. We want to find the measure of angle Y, angle Z, and angle W. So let's mark that angle X is 156 degrees. Well, since it's an isosceles trapezoid, our base angles are congruent. So that means angle Y is 156 degrees. Then our leg angles are supplementary. So to get angles W and angle Z, I can take 180 minus 156, and I get 24 degrees for angle W. And then angle Z will be congruent. It is also 24 degrees. Okay, number two says half of a spider's web is shown, formed by layers of congruent isosceles trapezoids and triangles. Find the measures of the angles in quadrilateral ABCD. So a key word here is isosceles, which tells us that our base angles will be congruent in each of our figures. And we're also told we have half a spider's web. So in our figure below, we have a six-sided figure, which tells us that a spider's web would have 12 sides. So there's 12 sides in a spider's web. So if I want to find the measure of each of my angles, going back to chapter 3, we'll use that formula, number of sides minus 2 times 180, and then we'll divide by how many sides there are, which is 12. So we have 1800 divided by 12, which is 150 degrees. So that tells me the entire angle here, so all of these angles that I'm marking are 150 degrees. So we have 150, 150, 50, 150, 150. So angles A and angle B will be half of 150. So to find A, if I take half of 150, I get 75 degrees. Since it's an isosceles trapezoid that angle A and angle B are part of, their base angles will be congruent. So angle B is also 75 degrees. Now I have a trapezoid here, ABDC. So my base angles are congruent and my leg angles will be supplementary. So to find angle C, I can take 180 minus 75 because angle A and angle C are supplementary. And I get 105 degrees. And angle C and angle D are congruent because they're the base angles in my isosceles trapezoid. So angle D is also 105 degrees. Alright, in number 3, we're going to find the value of the variable in each isosceles trapezoid. So remember, in isosceles trapezoid, our base angles are congruent and our leg angles are supplementary. So in letter A, we're given two base angles, angle S and angle R. So we can say 5x equals 60. Divide by 5, we get x equals 12. In B, same idea. 3x equals 45. Divide by 3, x is 15. And again, same idea in C. 3x plus 15 equals 60. Subtract 15. 3x equals 45. Divide by 3. X equals 15. Alright, now we're going to look at kites. There are 3 kite theorems. The first one says the diagonals of a kite are perpendicular. So that means we form 90-degree angles in the center. 2, the diagonal that extends from the ends of the kite is the perpendicular bisector of the other diagonal. So key word there, bisector, which means it's cutting the angles in half and making them congruent. And finally, number 3, the diagonal that extends from the ends of the kite bisects the angles at the ends of the kite. So same idea there, it's making the angles at the ends of the kite congruent. So bisects is our key word there. Alright, let's look at some examples of kites. In number 4, we want to find the measure of angle 1, measure of angle 2, and measure of angle 3. So I'm going to mark down the 3 angles we want to find. Again, might not necessarily be in this order. Alright, so I have a kite. I know my diagonals are perpendicular. So I have 90-degree angles in the center. So angle 2 is 90 degrees. Now our third theorem said diagonal makes the angles congruent at the ends of the kite. So I know these angles are congruent. So angle 1 is also 72 degrees. Now to find angle 3, it's in triangle RDU. So if I take 180 minus 90 and minus 72, I get 18. So angle 3 is 18 degrees. That would also make this angle 18 degrees as well. Alright, letter B. Again, finding angles 1, angle 2, and angle 3. Alright, well we can easily find angles 1 and 3 first, right? Our diagonals are perpendicular, so angle 1 is 90 degrees and angle 3 is 90 degrees. Well, since this is a kite, our angles at the ends of the kite will be congruent, so this side is also 50. So to find angle 2, take 180 minus 90 minus 50, we get 40. So angle 2 is 40 degrees. And finally, letter C. So angle 1, angle 2, and angle 3. Alright, so diagonals are perpendicular. Angle 1 is 90 degrees. These angles are congruent, so angle 3 is 45. And to find angle 2, take 180 minus 90 minus 45 makes angle 2 also 45 degrees. Okay, let's look at our last kite example. Number 5 says given kite PQRS at the right with ends Q and S. If the measure of angle PSQ is 19, so that's our angle down here, measure of angle PQS is 47, so our angle up top is 47, RT is 6, so that's our side, and PQ is 10. We're going to find some other missing parts in our kite. So remember, in a kite, our consecutive sides are congruent. Our diagonals are perpendicular. That means we have 90-degree angles in the center. Okay. We also know that our angles at the ends will be congruent. So that angle is 19, and up top, this side is also 47. All right, so letter A says RQ. Well, RQ is also 10. It is congruent to PQ. In B, measure of angle PTS. So PTS is just our right angle in the center. So that's 90 degrees. In C, angle TPS. So that's this side of the angle here. So to find angle TPS, we'll take 180 minus 90 and minus 19. We get 71. So it's 71 degrees. In D, we want to find the measure of angle PQR. So that's the entire angle at Q. So 47 plus 47, or 94 degrees. Letter E, measure of angle QRS. So that's our entire angle on the side. So if angle TPS was 71, that makes this side also 71. First we need to find angle QRT. So if we take 180 minus 90 and 47, we get 43 degrees. So that means this side, the angle is 43. So we'll have to take 43 plus 71 to get 114 degrees. And finally, side TP is 6. All right. So just by given a few angles and sides, we're able to find all our other missing parts in our kite. So this concludes section 6.5, Trapezoids and Kites, and also concludes chapter 6 on special parallelograms.